Assalamu alaikum everyone. First of all, it's really an honor to be here as an invited speaker. Today I will be sharing our work in the domain of Swam robotics and particularly AI on the edge. So this is the outline of my presentation. For students, I will be a bit more simple and easy to go, so that we are not going to in detail, or we can say too much technical details of algorithms and so many things. So overall introduction, then scope, then what are the application areas where we can use these robot swarms, and then we will see different experimentations related to swarm intelligence algorithms, not only in the simulation as well as on different hardware platforms. And finally, I will conclude my talk with computer vision and AI on the edge applications. So, starting with the introduction related to swarm robotics. So actually, when we talk about swarm, so here we are not talking about a single robotic agent. We are talking about multiple different robotic agents, but again, in some formation control mechanism to have some sort of collective behavior. Like if we look at different species around us, like how different birds are moving, similarly ants and other these kind of species. So they are doing many tasks in their collaborative behavior by using their own essence, logic, intelligence with very simple rules. Like here we can see an example where a termite mound is built by centimeter scale different insects, and the termite mound they build, it is actually around 10-30 meters long. So this is how that collective activity resulted in achievement of something big. Similarly, if we talk about the same behaviors in robot swarms, so actually in robot swarms we are going to couple these biological inspired intelligence algorithms with robotic agents. So ultimately these robotic agents are going to be capable enough or intelligent enough so that they can achieve a collaborative task, they can achieve a particular goal they have been assigned. But when we talk about how we can see these robot swarms, how many different agents will be there, what are the different capabilities or basic characteristics of these swarms would be there. So generally we can see in a node swarm, usually it's mandatory to have at least 3 different nodes. So if the swarm of 2 robotic agents is not considered as a swarm, so generally the 3 robotic agents should be there. Then there should be limited human control. We can't even have a totally autonomous behavior, because to some extent they can even ruin everything. So the limited human control should be there in these robot swarms. And obviously the cooperation is the key. The cooperative behavior, that is the key. If we talk about different behaviors of these robot swarms, so generally the behaviors are categorized into aggregation, flocking, foraging, navigation, path formation and task allocation, where sometimes these robotic agents are looking for a particular task, for searching something interest, similarly maybe moving towards a particular goal in a formation like pattern. So there can be any different tasks like out of these which we can consider as a behavior of robot swarms. If we talk about the scope, like this is basically a scope on which we are actually working on, but talking about in general, swarm robotics is much beyond this level. Like we are actually working to have different R&D solutions scalable on different platforms, UAVs, UGVs, as well as AUVs, or we can say ROVs. And the key domains on which we were actually working are swarm intelligence, decentralized communication, and computer vision and AI. So actually the first 2 domains, swarm intelligence and decentralized communication, they are actually there to have a collaborative intelligence behavior that we have to impart and deploy on board robotic agents. And from application side, we are actually working in the domain of computer vision and AI, so that we can get some benefit out of those robotic agents to achieve a certain goal. The application areas which we were targeting, it was particularly the defense sector, because looking at the modern warfare, so many countries are nowadays working in UAV swarms. So the defense sector, then video surveillance and monitoring, scene understanding, and particularly one of the challenges that Pakistan is right now facing, that is the disaster management. How we can get a real-time picture, how we can establish a quick emergency system. So these are the areas in which actually we are working on. And similarly, to deploy these algorithms, we are also working in indigenous development of different robots like miniature robots, UDVs and UAVs. So these are the different application areas like area surveillance, where we can have anomaly detection, border surveillance, crowd analysis and object recognition. For disaster management, we can have a quick real-time feedback about flood affected areas, wildlife fire, search and rescue missions can be planned, area exploration can be done by using these robot swarms. And academically, we can have different new kind of mobile robots. We can transform these multi-unit systems into a robot swarm. So for students, I would like to just give a big picture like how a particular task can be accomplished by robot swarms. Like here we can see there are two set of incidents happening in this picture. One is basically a fire incident and other one is actually a person having a pistol in hand. So actually we can say there are two anomalies. So how this whole process is actually working on, for example, if we are having some area service units, obviously that complete force is going to navigate over the area, explore the area and ultimately finding one activity. Like for example, there are few nodes who are basically targeting the fire incident, and similarly another sub-swarm is generated connected with the main ground control station as well, and that sub-swarm is going to deal with the other anomaly. So this is just an idea how we can have different robotic agents achieving a certain task or goal in a formation or more intelligent pattern. So coming towards all these different domains, I will start giving some examples about the algorithms. Like, so we initially started with simulation of different algorithms. For the first one is basically a decentralized pattern formation and navigation approach for swarms, a multi-UAV approach, in which actually we were having different UAVs which are placed in a clustered environment with obstacles. All these UAVs are actually searching other close UAVs by using various neighbor search algorithm, and then we have a basically train talent map is also there. That we have using Octa map. And finally the RLT algorithm, the rapid exploration algorithm, generates a clear feed path for individual UAV navigation. And finally multiple algorithm was used for the localization, and ultimately all the mobile robots which are built in dispersed manner. So after execution, they are finally aggregated towards a particular point. So this was the first algorithm we tested in a simulation platform, Gazebo. Then we move on, and this was basically our a multi-platform hardware in the drone simulation for decentralized swarm communication, where we actually emulated our different nodes by using hardware in the loop testing. And here we use micro-arc model, which are basically acting as an individual UAV, and both are basically connected to a ground control station. And finally, these emulated individual UAVs are performing a communication task for the set purpose. Lastly, we experimented in comparison, that is sub-swarm generation. Again, the simulation indicates there are 11 different nodes, and here they suddenly identify one anomaly of 5 incident there, and ultimately the rest of the nodes are moving towards the next target. But this particular node established a team connectivity, because when we talk about the sub-swarm generation, so in sub-swarms there are different swarms are in existence, and how we are going to connect them to the central ground control station. So obviously there is a relay node that is involved, that is basically establishing. So this was a simulation in configuration and ultimately giving the code. Then comes to us how we are going to use these algorithms, where we are going to deploy these algorithms. So we develop different platforms. Few of us develop indigenously, and similarly few are basically being used off the shelf. So for example, this is one of our projects as well, named as SimBot, a miniature bot that we developed in our lab. And this SimBot is actually intelligent enough. We are having three different variants of this miniature robot. One is basically a base tuner, then the other one is also having an onboard computing source, and the third one is also having a camera along with the accelerator. So these agents, like here you can see, they are basically running a SLAM algorithm, and they are actually simultaneously localizing and mapping the environment. So this was also being sent to an international competition as well. So this also won the competition locally here. Similarly, we also participated like the TechCon. We have been the finalist of OpenGPT competition, and similarly the Robotics startup at NCRA. So this work was basically presented not only this miniature robot but also the algorithm deployed on this robot. The next part we have an indigenous development again and collaboration with one of the industry. This is basically named as Black Hawk. This is a UAV that we have used in our experimentation, equipped with Jetson Xavier, along with the communication module micro modem. Then for supervisors we have XMR, we have another computer source here, the Pi. Then comes to the camera. There are dual cameras here. One is the little camera, the other one is the studio camera. And for localization, we have the GPS layer 3, and finally autopilot quiz on or in cube is there. So this is basically another platform for the testing of different form of algorithms. Then before deploying our algorithm directly on the UAVs, we also use a UAV as well, because directly deploying algorithms on UAVs it's very difficult and again risky as well. Because one of the UAVs even very costly, we will look at it, and we use the UAVs for this purpose as well. And again, the UAVs are also going to have a similar kind of equipment there, because we just want to make the uniform platform. This is the UAV we use RDOS, this is the US product. Also having the RN2 quick hop, then GPS layer 3, again the same camera, Jetson Nano, Jetson Xavier, both of them, plus one more thing that is basically LiDAR, R2 LiDAR, which we want to use. So these are the three different platforms we use for experimentation purpose. Now coming towards the experimentation. Like here, you can see the first experiment, that is basically UAV Swam, having three UAVs. It's a homogeneous swarm because when UAVs are there, its position control is there, and force computing is done on board. Because as we say, all these units are equipped with computer source, Jetson board is there, so whole algorithm is basically being run on the UAVs, and it's a leaderless form. None of these nodes are going to be act as a leader. So this was the first experiment we performed just to maintain the formation control. Then we move on towards the leader follower formation. And for that, before going towards directly implementation on the UAVs, we initially tested the algorithm on the UGVs, where this particular node is acting as a leader. So this is a homogeneous 4 UGV swarm with follower control is there, and rest of 3 UGVs are following the leader here. So they are basically using a certain mission. As the leader is proceeding, the follower is going to follow that particular leader. Then this is just a homogeneous leader-follower swarm. Then coming towards the heterogeneous leader-follower swarm, where we are having couple of UAVs and 3 UAVs there. So this is basically 2 UAVs and 3 UAVs heterogeneous swarm in decentralized leader-follower formation, and it's completely autonomous mission, indicating the following area of the swarm. So here we will see this one is the leader. All other UAVs, this is the second UAV, 3 three UGVs are there, so they are following this UAV. At one instance, they were also tested what in case the needle is failed. Like here you can see the battery is drained, so the needle is no work. So automatically we have set a priority, the other UAV is going to become the needle now. So now this UAV is going to act as a needle and UGVs are going to follow that needle. Again, as the needle moves, so UGVs are going to follow that. Then comes a heterogeneous swarm. Again, in needleless formation, where we can see 3 UAVs and 5 UGVs are there. Out of these 5 UGVs, we use 3 UGVs in this experimentation. So the whole demonstration can be seen here, right? 3 UAVs are there. Then we can see the UGVs also in movement. So again, decent type heterogeneous swarm. Completely autonomous mission is there, and again the whole computing is being done under robotic agents. Nothing is being done at the server side, or the ground control station. So actually the whole computing is being done on the UAV as well as the UGVs, because both are equipped with the onboard computing resource. So as the formation is followed, similarly the UGV is also mimicking the same behavior. So this was all about different swarm intelligence algorithms. Now going towards the application side, like how we can use these robot swarms to achieve something. So just to demonstrate a particular example here, we can have an example that is a target detection and rescue. So for example, in this experimentation, so here we set a particular target, like this car is a target, and all 3 UAVs are now moving towards the target. They are basically searching the area, they are exploring the area, and within that area they are searching for the target. And for the time being we have set the target, this car. Clear? So once a particular UAV detected that target, so all other UAVs and UGVs are going to rescue that particular target. So we just want to have an application of just making the behavior that we may require in different search and rescue missions in real world, where we can see some target, maybe some person who is maybe needing some help in case of like the medical help may be required, sometimes food is required, sometimes life jackets may be required. So what we can do, we can have different UAV swarms which are basically exploring the area where they can find a certain region of interest, person of interest, object of interest, so they can ultimately send the information back to the ground control station, and ground control station send other nodes to provide different rescue opportunities. For example, in this case, this was just a mission, just an indication how we are going to achieve it. At next stage, what we are doing, we are also going to have a couple of drones which can carry load. So we are going to have some sort of search and rescue mission, like where a person may be needing help, and we can provide that help to that person by dropping medical aid, the food, and anything like this one up to a 5 kg weight in that particular. Similarly, we are also trying to establish emergency communication system by using different approaches so that they can connect towards some quick response force. Because whenever there is a disaster, so generally the very first thing that demolished, that is basically the communication and overall physical infrastructure. So we are going to use these robot swarms in these kind of situations. I also want to give you a few glimpses of AUV as well. We haven't tested this one for the swarming purpose, but we just are trying to have some initial experiments on this very robot as well. So all of these experiments which we can see here, they are basically showing how different robot swarms can achieve a certain goal. So if we just again look at this particular heterogeneous swarm, so we can use these heterogeneous swarms in different civil application areas as well. For example, the areas where we are going to have some missions. Like sometimes in our country we are dealing with different kind of procession, the gathering. So our law enforcement agencies, they are needing these kind of solutions where they can have aerial surveillance, where they can maybe look at number of persons, what is the behavior going on there, and then similarly how much area is being closed or affected. So all this we can do by using these aerial remote swarms. Now coming towards the application domain, again we have used the similar equipment again, the same UAVs there. So for that purpose we have developed this one of the platform named as OBDAP, On-Board Data Acquisition and Processing Platform. Why we consider the platform? Because it's basically going to process the real-time feeds on board. So we have tested different algorithms on our UAVs. So for example, this is the first experiment we performed for aerial object detection. So we tested the algorithm. This is basically a video where people coming over the mosque from UAV Tesla mosque, similarly people moving within the campus. So the whole computing is being done on the aerial unit. So algorithm is not only tested on the server side but also deployed by using NVIDIA Jetson data board. So our UAVs are equipped enough to process the real-time data. Similarly, the next demo, that is basically the crowd estimation and crowd analysis, we can say. So this video basically a dataset video, and this one is basically the people coming out of the mosque, and we are simply calculating the estimate how many persons are coming. And now we are extending this work where we can simply see what is the behavior of the crowd. So how the crowd is going to act, are they in cool and calm mode, are they in the agitating mode. So this is going to help the law enforcement agencies to deal with the situation. Another issue that world is facing right now in the last few years, we have seen so many incidents of the forest fire. So again, the same UAV swarms are going to use to detect the fire incidents within the urban as well as the forest areas. So we can simply get an estimation about first the detection, then the estimation, and even we can extend towards what will be the flow, how much which fire is going to affect, and what are the next areas that are going to be affected. Similarly, we can even use UAVs, a bit large scale UAVs again, that can carry different balls, the fire safety balls, and we can throw those balls to those areas so that we can stop spreading the fire. Then this is just again demonstration of object detection and tracking by UAVs. Again, the whole computing is being done. This is another experimentation being done on the UAV, that was semantic segmentation. We are trying to couple this semantic segmentation along with the object detection algorithm. Reason, like in Pakistan recently we have been affected with a flood. So how much area has been affected? How much devastation has been there? Like how many buildings have been collapsed? How many bridges have been collapsed? What is the situation of highways? So we can get a clear picture. Maybe at one point we can reach, but from that point we can't have an approach there. So we can use these aerial images and we can process on board to get the idea about how much collapse has been done. And there exists many data sets, like data sets for flood affected areas, similarly for the earthquake affected areas. We will use those data sets for the disaster damage effect assessment. And we are basically trying to replicate the same thing for our local environment. So there are a few more works that we did, and we are trying to do it on the, again, AI on the edge side, like human behavior analysis, anomaly detection, and lastly this one is basically a work collaboration with our UK partner, that is basically fault detection, and we are trying to do it in the real time as well as deploying in the edge-based solutions. Like we are using Raspberry Pi along with the OB device for the purpose. Then there are a few more allied applications we have been working on, like payment distress detection, multimodal speaker recognition, and then the plant work disease detection. And finally, this is a very interesting project for the students because in Pakistan we are having an issue of soft skill, the presentation skill. So our students are being suffered with this one. So we are trying to develop a tool that is going to assist students for their self-assessment of presentation and communication skills. And this tool is not going to assist students, but also going to help teachers to evaluate their soft skill. Because being a teacher, it's very difficult to have a clear picture about a lot of these parameters. So our tool is basically going to help students as well as teachers to have a quick assessment about the presentation skills. And this is again a totally multi-module course is going to be. Not only the vision, but also the audio data is being captured, and we are working in the behavior, like how the arms, leg movement, the body, the gesture, the posture is there. Similarly, what is the quality of speech is there, how many different filler words are going to be there. So this is the work we are actually working on as well. And again, it's going to be a very handy solution for students as well. Even they can have an app later on, but recently we are now just developing the website, web app for this one. So this is all from my side. The house is open for the questions. And once again, thanks to kids and you to the art for inviting me for this one.
Questions from the audience. So I have a question.
Yes, sir.
Regarding the Swam, you talked about offensive. So what about the defensive side? So if we have a Swam attack, how to actually deal with that?
Yeah, this is basically a question that the few that many persons also ask from us, like how we can deal with that particular. But that is totally a different domain. That is not basically we are trying to cover. Because for that we need some very delicate hardware on the ground station side that is going to detect that particular attack. So that we are right now we are not discussing, but recently we started a work where we can have some sort of air-to-air drone detection as well. Because people have heard that side where we can detect drones from the ground side, but now we started working on the air-to-air drone detection as well. One very common work recently published by, I think it was UCF group, it was basically named as Dogfight, where we can detect. So this is one way to deal with that particular situation.
So another question is that what happens if the leader is compromised by spoofing?
Yeah, in that case, just like we give an example, like if leader is basically having a battery issue or something like that, sometimes it's going beyond the public area as well. So we have set,
It's not going down, it's being spoofed.
so again, we have to set a priority in the system, like the other one is going to take the role as a leader. So that we have already said, like just like going to be the face rate mode. Like in really very common and familiar with the face rate mode. So the similar thing that we have established in the algorithm, so that you can deal with that particular situation.
Failing is the condition that is detectable.
Right.
Proofing is the condition which we actually misreading.
Yeah, but again, at one slide, I indicated about, just a minute. Yeah. Basically, this was the basically part where limited human control. Because we are not going to leave it totally open-ended. Because the issue is that in that case, the whole swarm even can be hunted. So obviously, there should be some monitoring and something that is going to be done in the ground control session. So if anything is going to happen like this one, so we are going to intervene in that situation.
One last question, we showed the black hole, right?
Yeah.
So what is the approximate cost that we can share with all these are component based, right? And also
Yeah,
just component.
exactly.
So these are off-the-shelf components.
Yes, exactly.
So what can you share the approximate cost of building these something?
When we got this equipment, our company very junior. Because we worked on the specification, the design side, and ultimately a third party basically provided this equipment. So at that time, it costed us around 750K. Through proper government intervention. Like Pepper follow recently, because even we was company of first venture. So they supported us in a way that if this is going to be successful, they are going to pitch the same equipment to many others as well. So later on, they took the same equipment to another institute and they were costing them too much. But it's not going to be too much costly. Even right now, if we are having a design people and we are having a facility like the major industries in Pakistan are having a CNC machining, 3D printing quality, so we can develop this kind of equipment easily. and it's not going to cost even now more than 1.2 million. Because when we deployed at that time, dollar was around 154 or 55 rupees. So this is basically just a prototype. We can have much more optimized versions. Like here, we can also see why it's going to cost me. Like here, we are having Western Xavier board along with the Raspberry Pi board. Because initially when we tried to experiment with things, we just assumed that we need both computer resources there. But when we experimented, now we are thinking like Raspberry Pi is going to be and we can remove this one. So we can only use the Western Xavier for the computer purpose. And that is also handling this orange cube as well. Yes, sure.
You showed something which is like aerial view where you can be travel and also mixed with vehicles and other transport.
Exactly.
So can you do the analysis on crowd movement or crowd responsiveness or crowd analytics in that?
So that we are not targeting actually. We haven't actually tested the crowd counting algorithm on the UAV side.
Counting is one thing.
Yeah, exactly. But not behavior is everything. So that we are going to do in the future. Because that is required with a large machine message.
We got this problem later.
Exactly.
Any other
Any-
questions? Okay, let's thank our speakers.
Now I request Dr. Amir Mahmood to present shield to Dr. Muhammad Harun Yusuf. Please, sir, come and receive the shield.
I'm also having a charge for it. I'm doing that.